So here we have the blast furnace. This is known as the blast furnace. And here we reach up to even nearly 2200 Kelvin. So it's a very high temperature process. What happens here, from the top, we feed ore, coke and limestone. Ore, coke, limestone, the ore we are taking is right now, let's say, hematite. What will happen? 8:4:1 ratio we have added up. From below we put the blast furnace, blast of air from bottom. So more temperature will be generated here, and as the air goes up, the temperature keep on getting reduced. So what happens? We have two temperature ranges. We have to remember them: 500 to 800 Kelvin, that is low temperature range, and 900 to 1500 Kelvin, that is high temperature range. So I've created a small shortcut for you to remember. So instead of remembering different reactions given in the NCERT, just keep in mind that Fe2O3 get reduced to Fe3O4 or FeO. Both the reactions are possible. Reducing agent, everywhere we will take carbon monoxide, because I just now explained also that even though we start from carbon, but carbon monoxide being a gas will be able to reach to the oxide easily, and because it is a gas, it can travel faster to the oxide and will reach to each and every corner of the oxide and will do majorly the reduction process. So what happens here? Fe2O3 reacts with CO and forms Fe3O4. CO2 goes out, or FeO. At this low temperature range, FeO will not convert to Fe. So Fe2O3 becomes Fe3O4. Fe3O4 reduced to Fe, but FeO does not reduce to Fe. On the other hand, from 900 to 1500 Kelvin, FeO will reduce to Fe. So this shortcut you can remember that FeO to Fe conversion is not possible at low temperature, but at only high temperature. Remaining all from higher to lower oxidation state reduction will happen at lower temperature. Apart from that, calcium oxide, that is formed by CaCO3, that is limestone which we added here, which became CaO. CaO is going to act like a flux. SiO2 is the gangue, and we get the slag as CaSiO3. Here one very remarkable property you will see, this thing will settle down here. So molten iron will be settled at the bottom, molten slag at the top. So we understand that density of molten iron is more than the density of molten slag. That is why the molten iron is deposited down. And very smartly in this process we are going to use this information, because the molten iron is going to be heavier, it will be settled down. So one exit path here we have taken out. So here the molten iron will come out, and above there the waste molten slag will go out. Also, the molten iron coming out is pig iron. Pig iron is one of the most impure form of iron you can get. From here, one question will come from here only, the reactions and temperature. One question from pig, cast and wrought iron. One of this question came in the JEE Main 2020. This latest examination also of JEE Main conducted by NTA. So here देखो यार, in pig iron we have 4% carbon, which is sufficiently large quantity, as you can see the remaining. And the other impurities are sulfur, phosphorus, silicon and manganese. How to remember? My name is Saurabh Pant. So you can remember Sp Sir manganese. So Sp Sir manganese and 4% carbon is there in pig iron. How to convert pig iron into cast iron here? We have to heat the molten pig iron, that means pig iron melt, in the presence of air, iron scrap and coke. So we will get cast iron, which contains only 3% carbon, and it is hard and brittle. So pig iron is not brittle, but cast iron is brittle in nature. Then if you heat it further in hematite lined reverberatory furnace, hematite is Fe2O3. So hematite lined, that means there is a furnace. You don't have to worry about reverberatory furnace at this point of time for revision. It's just a heating vessel, we can say, a vessel where we are going to heat up. So we take a furnace coated with hematite, and there we take cast iron, and the cast iron will become even more pure, will get the purest commercial form of iron, that is known as wrought iron or malleable iron. And this iron, that wrought iron or malleable iron, is the purest form of commercial iron, was the question which came in the JEE Main 2020 as well. Anyway, so how this conversion happens, how the cast iron becomes wrought iron, or how it becomes more pure? What we did, we took a hematite coating. It contains carbon. Impurity is majorly carbon only here. Impurity is majorly carbon. So when you give hematite lining, that hematite reacted with the carbon, formed iron, and CO gas went off. So what happened? iron content increased, carbon content reacted and decreased. So here purity of iron increases. So wrought iron or malleable iron is the purest form of commercial iron available for us. And this was the question for JEE in 2020 also. Very, very important question. Make sure from this you can expect one question in the NEET examination. These are the reaction given. In the aluminum diagram, I will explain even better that which temperature exactly we will take. But right now, this much is more than enough. So let's go on to the next process of metallurgy. So this was an example to explain smelting process. It is a pyrometallurgy technique, extraction of iron. So Fe2O3 was the starting material, converted to FeO, Fe3O4, and FeO at a higher temperature becomes Fe and you get your desired metal. So pig iron, cast iron, wrought iron. And wrought iron, all these three uses of all these three type of iron you will find at the end of the NCERT in the uses of copper, aluminium, iron and zinc. So make sure that you read that also. So let's now magically enter into the second part of this reduction process.